In this video, I'm going to give you some tips for solving the ALEKS problem called distinguishing mixtures from pure substances through physical properties. This problem is going to give you a couple of samples with scenarios, and it's asking you to determine if these samples are pure substances or if they are mixtures, or occasionally you're going to be unable to tell from the provided information. Now, just in case you're not familiar with these definitions, a pure substance is something that just contains one type of material, one type of substance, one thing. I'm just going to say one thing. It contains all one thing, whereas a mixture is going to contain two or more things. And the key that you're looking for when you're reading these scenarios, these different sample situations, the key that you're going to look for is that when you have a mixture of things, you are going to see variation in whatever it is, whatever the situation is. It might be variation in a melting point. It might be variation in the dissolving process. It might be variation in the boiling process, or variation in density. Either way, there's going to be variation. If you have a pure substance, you're going to see consistency. You're going to see no variation in measurements, no variation in data. If you have a pure substance, there's going to be no variation. So let's take a look and let's apply that to these problems. I think sample B is an easier one to start with. This says we've got a substance, we've got 50 grams, divided it into 25 grams, and then dissolved it in water. The first sample took 101 milliliters of water, the second took 92, the third took 89, the fourth took 93. That is variation. That is an indication that this substance is a mixture, because there is variation in the amount of water needed to dissolve these samples. Now, I have seen some ALEKS problems where they did have a pure substance and they had slight variation in the measurements. Like maybe they said 93, 94, 92, those are all pretty close together, and ALEKS called that a pure substance, so be on the lookout for that. But even this much variability, that's a pretty significant variation. That means that it's a mixture. It doesn't even really matter, like we don't even really need to think about what is going on in this situation. We just need to see that there's variation in the data, which means we're looking at a mixture. Sample B sample A is a little bit trickier of a situation because it's not numerical. In this, it says we have 15 grams of a powder, put it into a funnel, and poured water over the top of it. Most of the powder disappeared, but some gritty black sand-like material is left. What is that? That is variation. That is not consistency. Consistency in a situation like this, consistency would be all of the powder disappears without anything else following that, or none of the powder disappears with nothing following that. So consistency would be that the entire sample reacts or behaves the exact same way. And since that's not what we observed, that means that this is a mixture. Now, another scenario that's not in mine here, another thing that I see has to do with the boiling points and melting points. So I'm going to just write boiling and melting points. Those are the temperatures at which substance melt and boil. And I've seen a couple problems where ALEKS is talking about the boiling point or the melting point of a substance. And again, consistency versus variation. So if you have a situation where it says it starts boiling at 63 degrees and it continues boiling until it gets to 77 degrees, that is variation. That is an indication of a mixture. Whereas if it says it starts boiling at 63 degrees and then it all boils away, and when it's done boiling, the temperature goes up, that is consistency. That is the substance staying at one temperature throughout the entire boiling process, which would mean that it is a pure substance.